So this is what we're doing. Oh, I need to do this. Yep. All right, here we go. We have to find our number. No, we have to, whoa, what are we doing? We are looking for the start here. Here's my start here. There we go. There we go. Hello, everybody. We, oh, nope, are looking at this abacus. Hi, hey, extra bacon cheese. How's it going? Okay, sorry. I just got on. Hello, everybody. Hello. So what we're going to do is we're going to read the abacus. Now, we got to do 3,509. That's the number we're going to do. Because we're going to do that number, well, what does it look like on the abacus? On the abacus, it looks like 3,123. That's what that looks like. And then we do 5. The top beat is always 5. Because the top beat is always 5, that's what's being counted. So this is 5. 3, 5, 0. 0 means that there's no beats touching this horizontal bar. There's no beats touching the reckoning bar. Because there are no beats touching the reckoning bar, this is what we call 0. And then this is 9. This is 5, 6, 7, 8, 9. So I'm going to color. We have 3, 1, 2, 3, 5. The top beat is 5, 0, so nothing gets colored. None of the beats get colored in. And then we do 9. 5, 6, 7, 8, 9. And then what are we going to do? We're going to go to our next number. Our next number is 3,611. That's what we're doing. So we do 3,123. Notice that the beads touching the reckoning bar is being counted. These are not being counted, so these are all zeros. So it's 0, 0, 0, 0, 0, 0. But we need to do 600. 600 looks like this. 5. The top beat is 5. The bottom beat is a value of 1. The value is what I'm looking for, right? The value of 5 is right here. So we have 5. 1, 2, 3, 4, 5. That's what the top beat is. And then the bottom beat is a value of 1. So together, 5 plus 1 is equal to 6. And then we have 1 and 1. This is 11. 11 is 1 10 and 1 ones. That's what it is. And this is 6 hundreds and 3 thousands. So we're going to color it in. We're going to color in 3,000. 1, 2, 3, 6, 5, 6, and 1 and 1. Okay, how are we doing? Hello, everybody. Hello. Thank you for joining. Thank you for joining. My name is Lynette, and we are reading the abacus. Thank you, everybody, for joining. Thank you, everybody, for joining. Please keep your mind open for something different.
Open your mind to me, please. Open your mind.
Thank you so much for liking the live. Thank you so much for liking the live. So what we're doing is we're just coloring and reading the abacus. That's what we're doing, because before we can run, we need to know how to walk. So the first thing we need to do is understand that we're going to have 1,908. So 1,908. How did I get that? Well, 1, this is the bottom beat. The bottom beat has a value of 1. And then we have 9. 5, 6, 7, 8, 9. When we look, there's a top beat. The top beat has a value of 5. So together, this is 9. So we know 5 plus 4 is 9. And then we have 0. None of the beads are touching this horizontal bar. So that means this is 0. And then this is 8. 5, 6, 7, 8. Again, we have 5 plus 3 is equal to 8. Now I'm going to color. We have our 1 over here. We have 9, 5, 6, 7, 8, 9. 0 is here. And then we have 8. 5, 6, 7, 8. So then our next number is this one over here, and I am following the path. The path tells me that I'm going to do 2,086. So 2,086. That's what that looks like. So we do 2, 1, 2, 0. That means none of the beads are being colored. So this is empty. And then here we have 8. 5, 6, 7, 8. We do 5, 6, 7, 8. We do 6, 5, 6, 5, 6. Great. So then after that, we're going to do 4,386. So we do 4,386. That's what that is. So how are we doing? My brain. The heck? Yeah, I know, right? The abacus wars. How does multiplication work on this? Sorry. So the first thing we're going to do is understand. We're going to do 4,000, 1, 2, 3, 4, 1, 2, 3, 5, 6, 7, 8, and then 5, 6. So I'm going to color it in. We do 4, 1, 2, 3, 4. We do 3, 1, 2, 3. We do 8, 5, 6, 7, 8, and then 6, 5, 6. Hello, everybody. Hello. Wow. Hello, everybody. My name is Lynette. We are learning how to read the abacus. Hello, everybody. Welcome, welcome, welcome. Hello, Lenny. Welcome back. I'm doing well. I just came on. Hello, TikTok T. Right? That was really strange. And I was trying to read all the comments. And I was just going to this person just blasted it. Anyways, so what we're going to do is we're reading. Hello. Hey, Shani, success. Welcome back. We're going to do 4,883. Welcome, welcome, everybody. Welcome. Thank you so much for sharing my live. Oh my God, we're at already 1,400 likes. We are going to do 400. 1, 2, 3, 4. I'm sorry, 4,000. This is the 1,000. We'll do 8, 5, 6, 7, 8, 5, 6, 7, 8, and then 3. 1, 2, 3. So we're going to do 4,000. 1, 2, 3, 4, 8, 5, 6, 7, 8, and again 5, 6, 7, 8, and then 3. 1, 2, 3. Yes. The blue bead, thank you, Benji. Yes, the blue bead will always be the value of 5. So if you see, this is 3. 1, 2, 3. When I add the 5, now we have 8. If I take away the 5, now we have 3. Well done. Why? Yes, thank you, Mikey. So the other reason why we don't start from here is because this is my decimal point places. If you notice, I actually have this label. This is my ones label right here in the middle, kind of in the middle. So this is my ones place. Anything after the ones, just like how we are in regular numbers, after the 1 is my decimal, and then after the decimal is my tenths and the hundredths. So we actually do decimals over here. Okay, good. Thank you, Mikey. Thank you so much for the comment. So if you notice, there's an actual label over here. This label will help us group the columns. So we have our ones, and then this is our thousands. That's why I start over here, because I know that this is my thousands. Ones, tens, hundreds, thousands. And that's it. Okay, so we have our next number is 8,290. So we have 8,000, 5, 6, 7, 8, 200, 1, 2, 90, 5, 6, 7, 8, 9, and then 0. So again, 0 is none of the beads are touching this reckoning bar, so that is why it's called 0. That's the 1 by the thousands. Yes, the thousands are over here. This is the 10,000s over here. So when we're looking, we have 10,000, thousands, hundreds, tens, and ones. And then we have our tenths and our hundredths. So when I'm going to color it in, I'm going to color in 8. We start from 5, 6, 7, 8. It's a kindergarten skill. They want the kids to learn how to count from any number other than 1. So Abacus kind of adds and provides the concept of adding, of counting on. So then I have 2 over here. So we color in 1, 2. We have 9, 5, 6, 7, 8, 9. And then there's 0. 0 is over here. Hello. Oh, yeah, not a problem, Natalie. Thank you. What is this called? This is called an abacus. Abacus. That's what it is. That's what this is. And so we're going to do 5,653. So 5,000. Oh, thank you, Carmen. Thank you so much. Yes, it is called an abacus. Great. So we have 5,653. So we have 5. That's the value of 5. The 5 will always be the top bead. And then we do 6. So we start from 5, and then we add the 1, and now it's 6. 5, 6. We have to do another 5, and then we do 3. Notice this is 3. 3 is less than 5. So we don't need to utilize the 5. We just count 3. 1, 2, 3. So I'm going to color in my abacus. I go 5 and then 6. 5, 6. This is 5. This is 3. 1, 2, 3. And that's it. How are we doing? Thank you so much. Thank you so much. I love reading the abacus. I've always wanted to learn. Thank you. Not a problem, Benji. Thank you so much for participating. I'm happy that you enjoy this. So, but when I'm done with this, it will be your turn. But for right now, let's continue on learning how to read the abacus, and then we're gonna switch the tables. So we're gonna do 9,865. So we do 9,865. So we have 5, 6, 7, 8, 9. The top beat is always 5. See? 5, 5, 5, 5. So when we're looking, we have 5, 6, 7, 8, 5, 6, and then 5. So when we're counting on our abacus, I'm going to color it in. We have 5, 6, 7, 8, 9, 5, 6, 7, 8, 5, 6, and then 5. Notice all the top beat is being is added to the horizontal bar. So that means these are all counted. I've always, oh, good, Shannon. Why is this? Yes, Danny, you can add, subtract, multiply, and divide on the abacus, but for right now, we're learning how to read the abacus. Hello, everybody. My name is Lynette. If you're looking for abacus books, I have available here or in my TikTok shop. Oh, maybe I should actually pin a few things just so it's easier for you guys to see. So I do have a bunch of books available. It is pinned. But if you want it here, I do have it here. My name is Lynette. Thank you so much for joining. My name is, okay. So we could do adding, subtraction, multiplication, and we can actually do division. Yes. Yes, we can do division. It just depends on how we're doing. Easy to follow. Thank you. Great lesson reading. Oh, great. Oh, so Joanne, the reason why we don't start over here is because if you notice we have our label. This is our ones label because there's a one label here. This is my decimals. So if our ones, just like in regular math, we have our ones, our tens, our hundreds, our thousands, or 10,000s. Then anything on the right side of the ones is my decimals. So we have our tenths and our hundreds. Great. I got to figure out. Yeah, we could do multiplication. We could try to do multiplication. Let's see how we do. So it depends. It also, obviously it depends on how big the class gets. So we have 5,494. So we're going to put 5,494. That's what we're doing. So we have 5,000. We do 4, 1, 2, 3, 4. We do 9. We do 5, 6, 7, 8, 9, and then 4 again. 1, 2, 3, 4. Now we're going to color it in. So we're going to color it in. We do 5. We do 4. 1, 2, 3, 4. We do 9. 5, 6, 7, 8, 9, and then 4. 1, 2, 3, 4. Welcome, everybody. Welcome. My name is Lynette. Hello, Natalie. For those of you that just joined, thank you so much for joining. Please keep your mind open for something different.
Now open your mind to me, please. Open your mind.
Our next number we're going to do is 4,289. So we're going to do 4,289. That's what that looks like. So we have 4, 1, 2, 3, 4, 2, 1, 2. We have 8, 5, 6, 7, 8, and then 9, 5, 6, 7, 8, 9. We're going to color it on the abacus. We do 4, 1, 2, 3, 4. We're going to do 2, 1, 2. We have 8, 5, 6, 7, 8, and then 9. We have 5, 6, 7, 8, 9. That's it. All right. So what are we learning? We're learning how to read the abacus. That is what we're doing, Josiah. I understand a little bit. Ooh. Oh, good job, Natalie. Guess what? It will be your turn after I finish this. We have to do 1,000. 1,000, super easy. So what's 1,000? That's 1,000. That's what it is. That's all it is. So how do we figure that out? Well, if you look, this is 1. This is 10. This is 100, 100. When we have place values, right, it goes like this. We have 100, and then we have 1,000, 1000, and then we have 10,000, 10000, 0.00. There we go. Thank you, old man hotline. Hotline. Those are so old. I don't think you're that old. I remember we had the party lines. All right. So are we ready? What are we doing? Are we ready to test your skills on how to read the abacus? So for those of you that have just joined, it is now your turn to understand how to tell me what you have learned. So we have our number. Which columns do you know which one to use? Oh, thank you, Ricky Lee. So here we are. Every column is a place value of our ones, tens, hundreds, thousands, 10,000s. That's why. So when we look, we have our number. What number do you think this is? We have our thousands, hundreds, tens, and then ones. What number do you think that is? What number? Yes, thank you. 3,412. Well done. Well done. Thank you, L. Thank you, Eugene. Duncan. Thank you so much for the roses. Thank you so much for the roses. Thank you for the gift. Thank you for the gift. Hello, Katie on the daily. Wow, that's a lot of roses. Hi, I got it right. Yeah. Hey, Lewis. Okay, so it is 3,400. Thank you so much, Eugene. So we have 3,412. Well done, everybody. So what is our next number? We have our, that's a lot of roses. I'm so impressed. Thank you so much, Duncan. We have our thousands, we have our hundreds, we have tens, and we have ones. What number do you think that is? We have our 6. Thank you. I am bored again. Right? We have 2, 6, 8, 2. Thank you so much, Eugene. It's going. It's going. That's crazy. This is so helpful. Thank you for keeping this art alive. Yeah, thank you. Thank you for participating. Oh my God. Thank you, Eugene. 350 roses. That's crazy. That's crazy. Thank you so much. Thank you so much. If those roses go to, then that's wild. Yes. I do like the roses. Thank you so much, Duncan. Thank you so much. Oh, I have to take a little breather. That's a lot. Thank you so much. I appreciate that. Okay, so it was 2,682. That's what it was. And so our next number is this. What would be our next number? I'm always curious how to read the abacus. Yes, we are reading the abacus. We're testing you out because then after this, we are going to go into adding, subtracting, and we see we can do multiplication. Thank you, Carmen. Yes, Carmen. Thank you. There we go. So we have 7, 5, 6, 7. We have 4, 1, 2, 3, 4. We have 4 again. I'm sorry, 7, 5, 6, 7. Well done, well done. Thank you, thank you, thank you. It is not Justin. Justin is not 3. What it is this is what 3 looks like. What we're looking at is 7. So we have 5, 6, 7. 1, 2, 3, 4, and then 5, 6, 7. Does that make sense, Justin? I wish I understood this. If you paid attention, you will. So we have 7, right? 7, 4, 7. 7, 4, 7. So our next number, what is our next number? So I'm going to color it in. We have our thousands. We have our hundreds, tens, and ones. So when we look, we have our thousands, hundreds, tens, and ones. What number? Thank you for showing me. Not a problem, Nada. I got it. Oh, good, Caroline. Yeah, right? 3,278. Thank you, TikTok T. Thank you, TikTok T. Yes. So what we're doing, hold on, champions. Hold on just a little minute. Let me read the number on the abacus. We'll do 3, 1, 2, 3. This is 3,000. This is 2, 1, 2. This is 7. How did I get 7? The top beat is a value of 5. So we have 5, 6, 7. So together we see 5 plus 2 is equal to 7. So what happens to 7? And then after this, it looks like it's 8. How do I know? Because it looks like it's one extra bead. We have 5, 6, 7, 8. 5 plus 3 is 8. So, champion, 10 just looks like that. That's what 10 looks like. I probably learned this for 3rd grade, probably. Yeah. Great, Patrick. See, you just need to sit around. I will explain it. It will be explained. So, champion, did that make sense? 10 looks like this. 1 and 0. So when we count, we do 11, 12, 13, 14. 1 and 4. 15, right? 1 and 5. 16, 17, 18, 19. And then this is 20. 2, 0. 2, 0. When did I learn this? I learned this like 20 years ago. Okay, so we have our 3. What are we doing? 3. I did not learn this as a child. I learned this as an adult, and then I started teaching it because my dad wanted to open up a learning center to teach children how to read the abacus. And then I decided to go on the internet and teach the matrix what the abacus is. So thank you, everybody. Thank you, everybody. Welcome to
the real world.
Thank you, everybody. I'm on Amazon. Oh, thank you so much, champion. Yeah, not a problem. Not a problem. Never have. So yes, that's what it is, right? I'm here to teach abacus. I'm here to teach the matrix how to use the abacus. So we're going to do this number. What number? Oh, thank you. I am bored. Thank you so much. It is 1,289. So if we look, we're going to count 1,002. This is 1,289. There we go. There we go. So for those of you that are interested, I do have books available in my TikTok shop, or I do have it available over here. My name is Lynette, and I've been teaching abacus for about 20 years. So I'm trying to spread the good word of the abacus. Is this the same as counting on your knuckles for each of your hands? I don't know. Johnny, I actually don't count with my knuckles in my hands. I don't know that family. I don't know that that methodology. But I do believe. Oh, thank you, Shannon. Did you want to see what? Did you want to see what it looked like? Okay, it was this one. So, just so you know, Shannon, let me just do a little review. Oh, that didn't work. So you got the abacus, which is great. And then, 17, right? 7. Okay, yeah. So here is the book that Shannon had purchased. Here you go. So here, I'm not going to give you this one because this one I colored it in. But there's a blank one, and all of these you have to do is you have to find it. So in the beginning of the book, just so you know, we have, you can put your name on it. And then here we have our big brain notes. I call it big brains because I believe doing abacus is big brains. I learned it goes in 3 minutes. Yeah, I am bored. All right. How do I learn my multiplication facts? Okay, hold on just a minute. So then what we're going to do is doing a little review of a flip through of what the book is. So this is the book. It is Abacus Mazes, 3 digits. What we're doing is we're understanding what? We're understanding the tens, the hundreds, the hundreds, the tens, and the ones. This was number 8. There we go. And I give you explanation like how to read the abacus. This is the number, and then what it looks like as a picture. And then then here you're supposed to color it in because I enjoy coloring. And then we talk about numbers from 5 to 9. After that is what we just did, right? We did a bunch of numbers, and then here you read the abacus, and you color it in, and then you do it again. This is how it's all together. And then it talks about 2 digits, so it talks about 10, 11, and 12, and where the place value is on the number. And then I do a little review on what the abacus is. So with the review over here, what I did was I just broke it up just in case for those of you that don't remember. And then we do it again for the 3 digits. We do on the 3 digits, every column is a place value. So we have our hundreds, our tens, and our ones. And then after that, I give you this thing called a mask maze, which is what I have right here. But I noticed that the paper is a little thin, so I give you the option to download a printable, so you can download on something that's a little bit thicker for your liking. I like to use a file folder, and then all I did was cut it and then printed it and cut it. So here is the mask maze that we're doing. Actually, we're doing the 4 digit. I do have it available in my other store. I'm going to bring it into my TikTok shop soon, but not right now. For those of you that are interested, I do have it here. My name is Lynette. Now, so what are we doing here? We are doing the 3 digits, and you just need to find the answer. So I give you the number, you color it in, and then you have to find the path. That's why you use the mask maze to cover the answer, because it's easy to see what the answer is. So that's why I give you the mask maze. And then if you notice, after I give you, I think 20. I should get a better understanding of this. But I give you a bunch of other mazes so you can go through. And then there is this thing called a reverse maze. The reverse maze is what? A reverse maze means that I tell you what it is, and I give you instructions. So I tell you what it is right here. I tell you what the path is. I don't know if you can see that. I tell you what the path is, and then you're supposed to color in what the number is. So you always go back the number. So here when we start here, right? Then I give you the number, and you have to color in this one, and that's what it is. And if you notice, I also have the answers in the back, and that is what the 3-digit maze puzzles are. Okay, so I teach 5th grade, and I can't wait to show. Oh, that's fantastic. Okay, I'm just catching up. Thank you, Shannon. I'm just catching up on all of the comments. Okay, so yeah, I got that. Yes, we could do multiplication in a little bit, but for right now, we are learning how to read the abacus. Teach the 5th grade. Yes, I'm actually in the process of making a multiplication one for the mazes as well. And then, yes, we could do addition, subtraction, multiplication, and division. Okay, great. So I'm a visual learner. The books without a demo does not mean much at first. Yeah, that's fine. Because that's what we're doing right now. Okay. I'll look up the Romans. Yeah, Romans, something that used our knuckles to count. I'll look it up. But I don't know if there's very many people. I don't know if there's very many instructions how to do it. Just like the abacus, there's not a lot of instructions how to do it. Okay, so before I forget, so what we're doing is we did 1,289. Okay, now we have this. Your back. Oh, thank you, Nada. Your book is magical. Thank you so much. Yeah. So what are the two columns on the right? Oh, yes. So the two columns on the right is the decimals. Thank you, Samuel. So when we're looking, we have a little thing right here. This is the dot. This dot right here is our ones indicator. So our ones indicator tells us that we are in the ones place. And so after the ones on the right side is the decimals. That's what that means. If this was taught in school, class would, yeah. Just yeah. So the ages of the kids, I was trying to start the kids young. I was trying to start the kids as early as 3. You could go 4 and 5. The reason why was because in Abacus World, they never focused on the young kids. I do have another book. It is the preschool book. This preschool book was meant to talk about how to relate the numbers to the abacus. And so we're going to actually go into it, and I can tell you about that in a little bit, if that's okay. But if we could put a pin in that, I'd like to continue on with the maze. Is that all right? How big can an abacus be? The biggest one that I have is about 23 columns. I do know a few people. That actually have a 27 column, but this is a 23 column. 27 is pretty long, but that's as big as I've got. And then I got a nice big one over here. That's a teacher's abacus right there. Yeah. So, what's the biggest number you can do? The biggest number you can do is as big as the number of that's on the abacus, right? So if the abacus only has 7 columns like this one, then my biggest number would be 99,999.99. That'd be the biggest number. But then, if I had the biggest number on that one, that's like 23 columns of 9s. So, yeah. All right. So, how are we doing? Thank you guys so much. Thank you so much for joining. My name is Lynette. We're learning how to read the abacus. So for those of you, please keep your mind open to something different.
Now open your mind to me, please. Open your mind.
So for those of you that are interested, I do have, I like the way you teach. Oh, thank you. Okay, so what number do we think this is? Let me color it in. So I have my thousands, my hundreds, my tens, and my ones. There we go. So we have our thousands, our tens, our thousands, our hundreds, tens, and ones. What number do we think that is? Oh, thank you, old man. Yes, it is 6,000. Right, 6,637. Well done. You're right. Thank you, Miss Dimples. Thank you, old man. Because when we're looking, we have 6, 5, 6. So you notice every top bead is a value of 5. So we have 5, 6, 5, 6. We have 3, 1, 2, 3, and then we did it again. 5, 6, and then 7. Notice that 7 has an extra bead. So 5 plus 2 is 7. If you see here, this is 5 plus 1 is 6. So thank you, Miss Dimples and Old Man and Joanne and no Josh Mo. It is not 6, 7. It's 6,637. Thank you, Edward. Thank you, Edward. Yes, thank you. So when we're going to color it in 6,637. That's what it is. So what's our next number? We have our next number. So I'm going to color it in. We have our thousands. We have our hundreds, our tens, and our ones. What number do we think this is? I'm brand new. Bring me up? Yes. What is the line depicts the beads that are being counted? Yes. So when the beads touch this line, that's what's being counted. Thank you, Edward. Thank you, Miss Dimples. Thank you, Old Man. Hey, Chaotic. Welcome back. Thank you, Caroline. And Joanne. Caroline. Ooh. Huh. So when we're looking, we have 9,000. We have 9,642. How did I get 9,000? 9,000. The top beat is always a value of 5. So we have 5, 6, 7, 8, 9. You can see 5 plus 4 is 9. And then we do it again. 5. Notice that the top beat is touching this line, this horizontal bar, this reckoning bar. Because the 5 is touching the reckoning bar, is being counted. So we have 5 and then we have 6. This one does not have a 5 touching, so it is not 9. It is 4. 1, 2, 3, 4. If the 5 was touching the reckoning bar, then that would be 9, but it is not. So this would be 4. 1, 2, 3, 4. We have 2 over here. Why? Because the reckoning bar does not have the 5 touching, right? So this is 2. 1, 2. Ha ha ha, Caroline. Right? Yeah, it's funny. It's attention to detail. That's what it is. So it's always about the 5 beat. The 5 beat will always be the top beat no matter what. Question: what would this method be useful in? Usually this would be for basic arithmetic. So it'd be adding, subtracting, multiplication, and division. And so yeah, literally, thank you, chaotic. It's literally anytime you use math, it's anytime you're adding, subtracting, multiplication, and division. Thank you for checking in. Thank you for checking in. If you touch my head, there should be an orange an orange heart me. Go ahead and check it in. So, the original calculator, funny, it's not a calculator, it's actually just a counting tool. It's just helping you count. It's just a simple tool to help you count. And it's different than the blocks, because I don't know if you know, there's these blocks that we do in school. So in school they have these blocks, but it's like a math manipulative. This abacus is a math manipulative. All right, so we did 9,642, takes me here. So I have this number. What number? Yeah, it's just a visual helper. It's a very visual helper. It is, and it's much faster. It's interesting. The fact that you could see the numbers, you become easy. Like, who would have thunk it? Who would have thunk it? Knowing what these numbers are, what they look like. So these are representations of numbers. The abacus just provides a representation of the numbers. And what we're doing is we're understanding how to read the numbers. So the first thing we do, thank you, chaotic. It is 2,953. Well done. Well done. Thank you, old man. Thank you, Edward. Yes, 2,000. How'd I get 2, right? 1, 2. This is 9. 5, 6, 7, 8, 9. And then again, we have a 5. The 5 is touching the reckoning bar, so this is what's being counted. So we have 5. And then there's no 5 here, so it's not being counted. So it's actually 1, 2, 3. So my answer is 2,953. Well done. Well done. Well done. All right. So what is after this? That's what the number is. 2,953. Our next number is, we have our thousands, our hundreds, and our ones. Our hundreds and our tens. We have our number. What number do we think? Oh, chaotic. That's really good. Thank you. Thank you, chaotic. Thank you, Jellica. Thank you, Edward, Miss Dimples, Old Man, and Victoria. Well done. Well done. So we have 1,009. 5, 6, 7, 8, 9. 5. Notice that the top beat is touching the reckoning bar. So this is 5. This is being counted. These ones are also being counted. So we're going to count 4. 1, 2, 3, 4. So we see 5 plus 4 is equal to 9. And again, the top beat is touching, so this is counted as 5. But notice none of these bottom beats are touching, so that means it's not being counted. This one is 7. How do I know? Because 5 plus 2 is 7. Anytime the beads are touching the reckoning bar, this is what's being counted. So my answer is 1,957. Well done. Well done. Thank you for the follow. Thank you. Oh, thank you for that garland and the hand heart. Thank you so much. 1,557. So that's what 1,957 looks like. So what's next? Hello, everybody. Thank you for checking in. Thank you so much. Okay, so what are we doing? We have our thousands, hundreds, tens, and ones. What number? Chaotic. You're so fast now. That's funny. All right. So how do we get that? Thank you, Edward. Almost, Edward. Thank you, Victoria. I've been practicing. So we have 1,953. 5, 6, 7, 8, 9. Notice the 5 is touching the reckoning bar, so this is 5. So this is counted. 5 plus 4 is 9. And then notice this one does not touch the 5 is not touching the reckoning bar, so this is actually 4. 1, 2, 3, 4. Thank you, Miss Dimples. And then our last number is 8. 5, 6, 7, 8. So we see 5 plus 3 is equal to 8. Well done. As soon as you explain it, I got it immediately. Oh, good. Oh, good, Diaz. Right? Makes sense. Good. It's simple to use, easy to understand. Thank you, everybody, for joining. Thank you, everybody, for joining. Please keep your mind open for something different.
Now open your mind to me, please. Open your mind.
So we have our next number. We have our thousands, our hundreds, our tens, and our ones. Welcome, everybody. Thank you, Jellica. Thank you, Miss Dimples. Yes, welcome. Yes. Thank you, Chaotic. Thank you, Edward. Edward, almost Edward. So when we're looking, we have to pay attention to the top bead, right? This is not 2. This is what 2 looks like. This is what 6 looks like. So we looked, that's not right. There we go. So when we're looking, we have our 1 and then 6. 5, the top bead is touching the reckoning bar. That is what's being counted as 5. So we have 5 plus 1 is 6, and then we did it again, 5 and then 5. So our final answer is 1,655. Well done, everybody. Thank you. Thank you. Thank you. So we did this. So we go down here, and then our final answer. And then we can start going into adding, subtracting. Oh, thank you, Netta, for the purchase. Okay, sorry. So our final answer. What is our answer? We have our hundreds, thousands, hundreds, tens, and ones. We have our thousands, hundreds, tens, and ones. How do we do? Yes, thank you, Miss Dimples. It is 7,821. 7, 5, 6, 7. The top bead is touching the reckoning bar, so this is counted. These two are counted. So counted as 5, 6, 7. The reckoning bar has the 5 in the top and then the 3 in the bottom. So this is counted. 5, 6, 7, 8. Notice it's 5 plus 3 is 8. And then we have this one. Notice the 5 is not touching the reckoning bar, so we don't count it. We have 1, 2, and then again, we only have 1. Thank you. Does that make sense, Diaz Gamer? Oh, yeah, you got it. Okay, good. So it makes sense, and that's our final answer. There we go. So for those of you that are interested, this book is available in the other store. I don't have this one available yet. It's still coming in. I'm still trying to stock up my store. For those of you that are interested, I do have it available over here. My name is Lynette, and I am an Abacus teacher. Thank you so much for joining. We are learning how to read the Abacus, and for those of you that just joined, please keep your mind open to something different.
Now open your mind to me, please. Open your mind.
Okay, so then you might be wondering, well, why are we using the abacus? Well, using the abacus because it's like a math manipulative. And if you enjoy math, or if you want to learn, if you want to be stronger in math and you want to be not scared, you can use this as a helpful tool. And that's what it is. An abacus is a tool. How do you do? Yes, you could do multiplication and division. Fractions is just another form of division, and we do parts of algebra, but not really. If you're looking for something algebra, I have a friend that does algebra. Let me know and send me a DM, and I'll send you her information. I make my son do this 10 minutes a day. Yes, I'm told he'll thank me later. Yeah. 10 minutes a day. You know what? 10 minutes a day is actually not that bad. Hello, mama. Okay. Whew. What are we doing? Okay. Well, we're going to understand how to use the abacus. Now, that's what we're going to do. We're going to understand, we learned how to read the abacus. We're going to learn how to move the beads. We're going to go into adding, subtracting, and maybe we go into division, multiplication, but I'm not sure. So, when we're looking, notice that the beads have an edge. You're going to use the edge to move the beads, just like that. That's all you're doing. And be gentle, right? Be gentle. The reason why you want to be gentle is because the beads are very easy to move. So if it's easy to move, it's also easy to get a wrong answer. So when you're doing it, you don't need to be aggressive. You don't need to pound it. It might also hurt. What you're going to do is you're just going to use and gently move your beads with your fingers. That's it. So the other thing is what? Oh, because it's easy to move. Because it's easy to move, you want to use your left hand to stabilize it. So you use your left hand to stabilize, and then you have your right hand to do the calculations. So then you're just going to move the beads. Now, don't forget, these are all fives. Remember, 5, 5, 5, 5, 5, 5, 5. These are all fives. But don't flick. Don't flick.
And flick. Oh, you flick too hard, damn it!
Don't flick. Because if you flick, you might get the wrong answer. Yes, thank you, Mike. It is a Soroban. Okay, so we talked about no flicking, aggressive. Don't be aggressive, and you want to be happy. You want to be happy, all right? So those of you that just joined, thank you so much for joining. Please keep your mind open for something different.
Now open your mind to me, please. Open your mind.
For what we just did, for those people that are interested, I do have the 3-digit book puzzle available in my TikTok shop. It is available over here. Let me see if I can do this. What am I doing? This one, right? There we go. And what it is I teach you in the beginning of the book how to read the abacus. This is what we just did, right? But you can look at it as a review, and then I also wanted to have them color it in. So the idea is to color in the abacus as well as understanding how the place values are. The place values is just a reminder of how we work with numbers. And so we have our ones, our tens, our hundreds. When we're looking at the ones, tens, and hundreds, right? How do you know with the rows? So when we're looking, I have these dots. Do you see the dots over here? This is my ones. There's 2 dots. So this is my label. This is my ones. This is my thousands. Just like how we have commas. Oh, what am I doing? Here it is. So just like our comma, right? When we do... Right. So when we're looking, there we go. We have 5,000. 5,000 is like that. 836. So when we look, we have 5,836. Does that make sense, Nita? So and then you'll notice that now we have our decimals over here. That's what these two are. Because this is my ones, my decimal sits between my ones and my tenths, and then this is my hundreds. Okay, good. So that's how you know. But you know what? If you choose, so you can actually choose this one as your ones place.
Pokemon, I choose you!
If you choose this one over here, if you choose that one over here, then that would be your ones, and you just shift everything over. If you shift everything over, then you can count. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. But notice, actually that's 20. But notice there's not enough room for hundreds. Because there's not enough room for hundreds, right? Then you cannot use this as your hundreds. However, now I have this whole to be my decimals. So if I wanted to be a really, really small number, I could be like 0.00001. That's what that would be. So, but that's why I choose this one over here.
Okay, Charizard, I choose you!
Because now I can shift everything over, and now I have my ones, tens, hundreds, thousands, and 10,000s. That's how we read the abacus. And every column is a place value. It doesn't matter what it is. It just matters which one you choose. That's all it is. Okay. So then again, just so for you to know, I gave you an option to do a mask maze. This mask maze, I give you the option to download the mask maze. The reason why is because I feel like the paper is a little thin, and so you have the opportunity to download and print it on a more thicker paper. So this one is what I used for us. And this is a file folder. I just put it on it. Sorry. So then what the maze is, you start off with the maze, and these are because I've already done it, but this will be blank, and your idea is that you color it in and then you do it on the abacus, right? Mimic the abacus. So this is 5, and then this is 7, and this is 5. So then you could see what the answer is. And then that's how I'd do it, is I'd use the mask maze, and then from there, from the mask maze, I'd use the and then I show it on my abacus. That's what I would do. And that's what the maze is. This maze, this is one style of the maze, and then there's another style. The other style of the maze is called a reverse maze. I give you instructions how to use it. This is the instructions. So what it is I start from here, right? Start at the label that says start from here, and I give you the number. It says 575. So the idea is that you color in the amount of beads into the abacus, and that's it. So that is the mask. This is the abacus maze. 3 digits. I do have one for 2 digits for children that are a little bit younger, maybe what, first grade, second grade, third grade, if you want to start them on that. I do have one that's 2 digits, and again, it's the same concept, but this time we're talking about the tens and the ones, and I still explain in the beginning of the book how do you read it on the abacus. And I give you pictures and diagrams, and then I give you a review of what it looks like, and then again, here's the mask maze and the ability to print it, and then I have this is, of course, this is done, but the idea is, again, color in the number, color in the abacus, and then find the path, find the answer. That's what that is, until you get to the finish line. And then, again, I have a reverse maze. So the reverse maze means the same, is exactly the same. I give you instructions how to do it. You get the number, and then you have to color in the number in the abacus before it. And then I give you the path. So I give you the whole path on how to draw it out. And then if you're ever curious and you think you got it wrong, I have answers in the back. That's what I got. So for those of you that are interested, I do have these available in my shop, or it is available over here. My name is Lynette. Thank you, everybody, for joining. For those of you who are joining, hello, Edric. Thank you. Welcome back. Thank you for checking in. Please, for those of you that are here, please keep your mind open for something different. It is not new. It is different.
Now open your mind to me, please. Open your mind.
Okay, so what are we doing? Now we're going to start understanding how to move the beads. Yes, I learned that in middle school Japan. I don't know what you learned, Mike. What are we doing? We're going to learn how to move the beads, right? What we're doing is we're learning how to move the beads. So we're going to review a little bit of what the preschool abacus is, and just to show you, here's a little flip through of what this is all about. That's this one is. That's this one. All right. So thank you, everybody, for joining. So now here's a little flip through, and then we're going to go into adding and subtracting. So the first thing we're going to do is understand, in the beginning of the book, I just talk about how to read the numbers and how it relates to the abacus. Thank you so much for liking the live. So here we are, just talking about the number 4, and then I have the activities just to strengthen and just be a little bit more engaging. This is a path. It doesn't matter what path they take, but they just have to find it. Awesome. Hey, Mac. Yes. I thank you for, I was wondering, oh, great, but wait, there's more. I'm just giving you an overview of what the book is. Oh, thank you for the follow. Thank you for sharing, Mac. So we have our lessons from lesson 2. We understand the numbers from 5 to 9. And then, again, it's just understanding how it looks on the abacus and how it looks on a piece of paper, right? So we have our numbers, we have our abacus, and then we have our items. What else do we have? This is not it. This is another piece of paper. And then we start counting forwards, and now we're starting talking about the relationship. We know how to count forwards, we count backwards, and then I give you the what comes in between, and then I have what comes before and after, and then after that I give you what? I do comparison, which one's bigger, which one's smaller, and I do it for a few times, and what's less than and what's greater than. So now we're going to get into understanding how to add. This is what we're going to be doing. In the book, No, in Abacus world, what we're going to do is we're going to understand what the second number is. The second number is what dictates whether or not we're going to use a formula or not, if that makes sense. The first thing we're going to do is understand that we don't need to use formulas for this. So here's my number, right? This is 7. If you notice, I sectioned the questions so that we're focusing on the add-in. We're focusing on the number 1. We're not focusing on the result. Mainstream focuses on the result, but in Abacus, we focus on the second number. It is the second number that dictates whether or not we're going to do anything. So we have 7 on the Abacus, 5, 6, 7, and my question is I need to add 1. Do I have enough to add the 1? Yes, we can. So we add the 1. That's all we're doing. So my final answer is 8. So we have that, and then what's our next number? Our next number is 2. Well, if you notice, when I add the 1, I'm just adding the 1 bead, right? It doesn't matter which 1 bead I'm adding. I just need to add 1 bead. So here's my question is 7 again. So I have 7 on my Abacus. I want to add the 2. See, I want to add 2. So can I add the 2? Yes, we can. Yes, we can. We can add 2. So we're adding 2. 1, 2. That's what we're doing. We add the 2. This is a counting tool. This counting tool just tracks your numbers. That's all it is. So as long as you know how to move the beads, the answer sits right there for you. You don't need to memorize anything. You don't need to memorize that part. You don't need to memorize your answer. You just need to memorize how to get there. So my final answer is the 9. And then we could do it again with a 3. So here's the question, 5 plus 3. We do 5 and then we do 3. My final answer is 8. You could, in mainstream math, right, do what mainstream math does. They could do the dots, which is fine, and then you just count up. You could do the tallies, which is fine. You just have the tallies and you count up. That's fine too. You can supertize. What is supertizing? Supertizing means that if you look at this object, you know what number it is. And I know that this is 8. How do I know? Because I know that this is going to be 9. These are all 9s. 9, 9, 9, 9, 9, 9, 9. So I know if I do this, this is 8. But now we can actually scale it. We can actually scale it. So we can do 5, right? 50, 50 plus 30. 10, 20, 30. So my final answer is 80. That's how I can scale it because it's a representation of the number. We have our ones, tens, hundreds, thousands, 10,000s. You could do the mainstream way and add your dots, but that's a whole lot of dots and that's a whole lot of counting. You could do that. Or you could do it on the Abacus. Let's do 500 instead. We do 500 plus 300 is equal to 800. 5, 6, 7, 8. 8, 0, 0. So that is what 800 is. And then what is 4? Well, notice when we add to the horizontal bar, it is being counted. So this is 9, and then I want to add the 4. And then my final answer is 9. And then here's the thing. If you know how to add, you know how to subtract. Why? Because it's the opposite. I have 2. I added 2 to the Abacus. Now I need to take away the 1. If I take away the 1, all I have to do is move it away like that. That's all I got to do. So what are we doing? So then we do minus 2, right? We have 3 on the Abacus, 1, 2, 3, and we want to take away the 2. When we take away the 2, it's 1, 2, we take away the 2. So my final answer is 1. Does that make sense? So you notice that if we have to add, we go to the horizontal bar, we subtract, we go away from the horizontal bar. And then we have 3. It's a minus 3. So we have 1, 2, 3, 4, and then we take away 3. 1, 2, 3. We take away the 3. These are the 3 that we take away. It doesn't matter what 3. We can take away this 3, or we can take away this 3. As long as you take away 3. That's all we're doing. Okay, so then we have 5. When we add the 5, we're adding to the horizontal bar. So we have 3 on the Abacus, 1, 2, 3. We're going to add the 5. When we add the 5, all we're doing is we're adding the 5 to the horizontal bar. And then we take away the 5, right? We add the 5, we take away the 5. We could do it again with the 6. When we do the 6, right? We have 6 on the abacus, and then we add 1. When we take away 6, we just move it away like that. We add the 6, we take away the 6. That's all we're doing. Hello, everybody. Hello. Welcome, everybody. Welcome. What we're doing is we're learning how to read the abacus and how to move the beads. So when we do 7, I'm going to do 7 like that. That's what 7 looks like. I'm going to add 2, and then when I take away, we just move it away from the horizontal bar. We add to the horizontal bar, we subtract from the horizontal bar. Thank you, everybody, for joining. Thank you, everybody, for joining. Excuse me. Please keep your mind open for something different.
Now open your mind to me, please. Open your mind.
So our question is 1. I add the 1 on the abacus, and then I need to add 8. Can I add the 8? Yep, I can add the 8. 5, 6, 7, 8 added together. So my final answer is 9. And that's it. That's it. That's all we're doing. All right. So how are we doing? Anybody has any questions? Whew. That was a little bit of run through. So the other thing is, let's do a little review. For those of you that just joined, thank you for joining. Thank you for joining. So what we're going to do is we're going to read the abacus. We're going to read 1, 2, 3, 4, and then 5. All the top bead that's touching the horizontal bar is considered counted. So this bead is 5. So we could do 5, 5, 5, 5, 5, 5. These are all 5s. But we want to do 5 plus 1 is 6. 5 plus 2 is 7. 5, 6, 7. 5 plus 3 is 8. 5, 6, 7, 8. And then 9. 5 plus 4 is 9. There we go. What's 10? 10 is just this. 1 tens. 2 tens. 3 tens. So this is 30. And then this is 40. And then after 40 is 50, 5, 0, 60, 6, 0, 70, 5, 6, 7, 7, 0, 8, 5, 6, 7, 8, 8, 0, and then 9. This is 90. 90, 5, 6, 7, 8, 9, and then 0. Okay. So how are we doing? How are we doing? Anybody have any other abacus questions? Let me know. Whew. Thank you, everybody, for joining. Thank you, everybody, for joining. Okay, so what's next? Well, what's next is understanding how do we make a 5. Why are we going to learn how to make a 5? We're going to learn how to make a 5 because we need to know what happens when we don't have enough beads. Oh, so it's like binary. It's kind of like binary from my understanding. Kind of like binary. Because if you think about it, on, off. That's what that means, right? Every column has an on and off. I guess it could be like that, right? Because it all deals with the reckoning bar. If it's on the reckoning bar, then it's counted. If it's off the reckoning bar, then it's not counted. Okay, so for those of you that are interested, we're going to understand how to add. This is a concept that we're learning. We need to remember that 4 plus 1 is equal to 5. Excuse me. 4 plus 1 is equal to 5, or 1 plus 4 is equal to 5. We need to understand this. The reason why is because we need to utilize this top bead. When do we ever need to know this? Well, we need to know it is when we start adding 4. Now, you might be wondering, I already know this. Well, I know you know this, right? We're old people. But we also memorized. We're not going to memorize it in Abacus world. What we're going to do is understand how to utilize it. So when we look, we have 4 on the Abacus. This is what 4 is, right? Let me do a little bit more props. Maybe this would understand. So there's my 4, right? 1, 2, 3, 4. 1, that's my 4. 1, 2, 3, 4. So then you might be wondering, well, I need to add this extra 4. Because I'm going to add this extra 4, I don't have any more loose beads. I can't do this because then this would be 44, okay? So I cannot use the tens column. This is the tens column. What I need to do is I need to add the 4 to the ones column. That's what I need to do. But notice I have no more beads to add the 4. So I can actually give you 5 cents. Because I give you 5 cents, then what? That's too much. I need to take away 1. So my final answer is 8. 5, 6, 7, 8. I could do it again on my abacus. I can add the 5, take away the 1, and my final answer is 8. 5, 6, 7, 8. So what did I just do? I understood this concept of how to utilize the 5. How to make a 5. That's the concept. right? We could do it again. Let's do it again. Here's 3. 3 on my abacus, 3 on my... What do I want to do? I want to add 4. But guess what? I have no more room. I have no more loose beads to add the 4. But I do have this nickel. I do have this 5 cents. Because I have this 5 cents, I'm going to add it. But that's too much. I need to take away 1. So I take away the 1. And that's it. So my final answer is 7. So when we look, we have 5, 6, 7. And then I can do it on my abacus. Add the 5, take away the 1. My final answer is 7. How are we doing? Woo! 11,000 likes. Thank you guys so much for that. Thank you guys so much for liking the live. Whew. All right. How are we doing? Does that make sense? Or should we review again? Let's do a review on how to read the abacus for those of you that just joined. Thank you, everybody. Thank you, everybody. So what we're doing is we're going to read 1, 2, 3, 4, and then 5. That's what the answer. This is the top beat. The top beat is 5. Yes, you're right, Jack. This would be 50. You are absolutely right. So if we do 50, what would this be? What number would this be, Jack? I have to talk to you because you're the only one commenting. What number would that be, Jack? Thank you, Edward. Oh, Edward, it's not 100. It is 500. Thank you, Juan. Yes, it is. It is 500. Thank you, Alex. Edward, this would be 100, right? If I did this, this is 5, right? This is 5,100. You have to, what we need to do is understand and pay attention to the reckoning bar. This reckoning bar, this line, the top bead, anything above, right? Anything above is a value of 5. Anything below is a value of 1. So all of these are 1s. So if I look, this is 4, 4, 4, 4, 4, 4, 4. And then we have 5, 5, 5, 5, 5, 5, 5. Great. So we're going to review again. 1, 2, 3, 4, and then 5. After 5, we have 6, 7, 8, and then 9. 9. Well, what's after 9 is 10. That's 10. 10 is that. So we did 1, 10, 100, 100, 1,000, 1000, and then 10,000, 10,000. How is that? How are we doing? Does that make sense? Thank you guys, everybody, for joining. For those of you that just joined, please keep your mind open to something different.
Now open your mind to me, please. Open your mind.
Oh, well done. You know, the two ones over here, that's really a good question. Why? Because that's what we talk about, the decimals. When we look, we have our ones. If you notice there's a little notch, there's a little indicator here. This is my ones indicator. This ones indicator tells me that this column is ones. So after ones is my decimals, is my tenths and my hundreds. Can you name that movie? Of course I can name that movie. It is Total Recall with Arnold Schwarzenegger and Shannon Stone. What's her name now? Sharon Stone. There it is, Sharon Stone. It's Arnold Schwarzenegger and Sharon Stone in Total Recall. Yep, Sharon Stone. Yeah, that was a name back in the day. She was like the greatest. She was like one of those hot actresses. Whew, Sharon Stone. Yeah, that's that one. So this can, yes, you're right. You're right, Jack. Thank you. So you're right. It is 99,999.99. That's what that would be. Yes, thank you. So let me write that out. So it'd be 99,999.99. I should do this. But this one specifically only goes up to 10,000, right? But I do have another one. And this is my 13 column one. My 13 column one goes up to, it depends on where you are. So if you look, Oh, you know what? Let me take that back. You know what? If I did this and I said that this is my ones place, oh, that's not going to work. I need, right. So if I said that this is my ones, if I said this is my ones, then it'd be this. It'd be 99.12345. 99999. That's if I use this one as my ones place. Does that make sense, Jack? So it depends on what you use as your ones indicator. How do you depict large numbers? Arnold Schwarzenegger. Yeah. Yeah, so it depends. And then the kids who do math real fast with the hands, are they simulating the abacus? Yes, they are simulating the abacus. And that's the interesting thing about it, right? So it just depends on where you see how there's a little indicator here. It just depends on where you are. So if you do this ones or this ones, that's all. And then, oh yeah, so that's what I was showing you. So here is my 13 column abacus. If I choose my ones over here, then I have my ones, my thousands, my millions, billions, and trillions, right? So it all just depends on where you want your one to be. And as long as you know where your one is, then it'll be easy to track. But that's what it is the abacus helps you track your numbers. That's what it does. It just tracks your numbers and it tells you what the numbers are. And there's a lot of power in understanding and seeing what the number is, as opposed to trying to imagine and remember what the numbers are. Because if you look, the numbers themselves is actually a symbol. The symbol, like a letter, right? A, B, C, D is a symbol. Numbers, the Arabic numbers, is also symbolic as well. So there's no real number of 2, but we know the concept of 2. We know that on the abacus, 2 would look like this. That's what 2 would look like. And again, we do 3. We see 1, 2, 3. So it's easy to see if we need to do anything with it. So if I want to add the 6, all I got to do is add the 6. And that's the interesting thing about it. Like in mainstream, there's this one person, they're like, the kids need to memorize how to make a 9. And I'm like, why? Why do we need to learn why do we have to memorize how to make a 9? Well, if you look on the abacus, we don't need to memorize this because it shows us on the abacus. If I want to add an 8, add the 1, do I have enough to add the 8? Yeah, I have to add the 8. I don't need to memorize it here because it just shows me. If I have 2, all it is 7. 5, 6, 7. Bring it together. That's my 9. And then we could do it again with the 6. So here I have 6 on the abacus. Guess what? 1, 2, 3. 3, there it is. Thank you. 120 degrees. Yeah. Yeah, that's these are very good questions. Thank you so much. So that's the interesting thing, right? Like you don't need to memorize how to make 9s because on the abacus, it already shows you. I have the 4, add the 5. That's it. There's my 9. Bada bing, bada boom. Bam. All right. Oh, so what are we doing here is we're understanding how to make a 5. I don't know if you guys were here for that. For those of you that are interested, this is what the 5 is. Why? We're not going to memorize what 4 plus 4 is. What we're going to do is we're going to utilize this 5. What we do, so this could be used in history to translate numbers across different... I think so. I'm sorry, I'm trying to read Jack's question. So could this be used in the history to translate across different numbered language symbols? I think so. I don't know what other numbered language symbols there are. Hello, Garden Lady. Welcome back. Jack, I'm not sure what other language symbols there are. But it can, I think it can. I don't know what they are. You could let me know, like, I don't know, like, the numbers in the Asian language and the numbers in American language, in English language. I guess. I don't know a lot of languages, so. Like Arabic numbers are different from all the others, look-wise. Yeah. Yeah, I mean, the interesting thing is the decimal system has been already adopted all around the world. So as long as they understand the decimal system, then it is easy to translate the numbers. Yeah, I think the biggest thing is understanding the whole concept of the decimal number system. If they use it as a decimal number system, then they'll understand how to use the abacus. I don't think it matters on the actual language. I think it matters on whether or not they use the decimal system or not. Yeah, I think so. Values are not numbers. Yeah, but he's talking about symbols, right? So symbols of four is different in depending on the languages. A lot of the Eurocentric math is Arabic numbers, but then when you get into like Swahili or you get into, I don't know, Thai, right? I don't know what those numbers look like, but it would be easy to translate. The reason why is because they have adopted the decimal system. Hey, Robert. I'm a little tired actually. Midnight math is a little tough. Yeah, but it's still the same value. Yeah, exactly, Juan. Exactly. It is still the same value because everybody because internationally the decimal system is being accepted. It doesn't matter if it's a different language or not. Yeah, you're absolutely right. It's all about the value. It's all about the value. It's not about the system itself. I'm sorry, it's all about the value. You're right. You're absolutely right. So when we're counting, this is 4. 1, 2, 3, 4. If I had, right, 1, 2, 3, 4. And then if I did 5, 5 would look like this. That's what 5 would be. Oh, can't see it. Yep, there you go. 5. That's what 5 is. Right? And then we do 6. We have 6. 5, 6, 5, 6. 7, 5, 6, 7, 5, 6, 7. We have 8, 5, 6, 7, 8. 5, 6, 7, 8. And then we have 9. 5, 6, 7, 8, 9. That's it. So anytime the beads are touching this reckoning bar, this is what's being counted. These are not being counted because they're not touching the reckoning bar. Ah, thank you, emoji. Yeah. And so it's very easy. It's simple to use and easy to understand. But it's also depending on, it always depends on who's teaching it. But I am trying to relate it to Eurocentric math because I believe it should be taught in mainstream. I believe the average people should know how to use the abacus. The funny thing is, right? The funny thing is the abacus is introduced to those people that are special needs or those people that are enrichment, and there's nothing in the middle. And I'm like, why doesn't the average people know how to use the abacus? Why is it only just the two extremes? And so I'm here to educate. No, I'm here to abacify the world. I'm here to teach the matrix how to use the abacus.
Welcome to the real world.
I think this would greatly help me for sure. Yes, I honestly can't believe I have never learned this. I'm 45. Yeah. My struggling math, but he's brilliant. I think I'm going to learn this with him. Yes, if he can visualize the math, I think it'd be very helpful. I think it'd be very helpful. And I have I have this one student. He's really good in math, but what I've noticed is that he doesn't know the actual numbers themselves. So he knows his multiplication table, which is fantastic, but he doesn't know that if you have 2 plus 2 plus 2 plus 2 plus 2 is the same thing as like 2 times 5 or whatever. So understanding math is different than providing the answers, and it's just different. Oh, okay. So here we are. We're doing this. What does that mean? Well, we're not going to memorize 4 plus 4. What we're going to do is we're going to understand how to utilize the numbers. So we have 4. We have to understand that 4 plus 1 is equal to 5. Because we have 4 plus 1 is equal to 5, right, we need to understand this. So guess what? Because I want to add the 4, I'm going to give you my 5. Because I give you 5, that's too much. I need to take away 1. So I take away one penny. Because I take away 1, I can do it again on the abacus. I add the 5, take away the 1. He's a kid who hates to show his work. Oh, yeah. I think this fits the way his brain works well. Oh, yeah. I think so too. I think this fits a lot of brains. And it's very interesting because there's a lot of people that come through my live and they say that they are either dyslexic, dyscalculia, dysgraphia, ADHD and ADD, and they come to this, and I show them what the numbers are, and they're able to relate to it pretty quickly. It's very interesting on how easy it is to show our numbers. So, yeah. And even though he knows his numbers, and even though he is, my kid doesn't like to show his work either, but you know what I tell him? I tell my boy is, you are trying to teach the teacher what you know. And I think that kind of helps him understand that he needs to write a little bit more why he got the answer. He has ADN dysgraphia. I am ADN. I'm glad I stumbled. Oh yeah. Yeah, let me know how you fare. Like, let me know how it works for you, because I do believe it is the greatest thing, because you could see the numbers. We don't have these symbols that we have to worry about. So we could do it again with a 3. Let's do 3. 1, 2, 3. 3 is here, 3 is here. 1, 2, 3. What we're going to do is we're going to add the 4. That's too much. What do? I have to take away 1. So my final answer is 7. 5, 6, 7. We could do it again on my abacus. Add the 5, take away the 1. And my final answer is 7. Another way we could look at it is, So another way we could look at what you just did is reduction, because it's the last piece not connected. Let me think about that one. So what you did is reduction because the last piece is not connected. Oh, yay! Garden Lady, I'm so happy your 13 column came in. Yes, it is like reduction. It is like reduction, because this is how I figured it out. We have 3 on the abacus, right? 1, 2, 3. 1, 2, 3. If I have my 5, 1, 2, 3, 4, but I only need 4. 1, 2, 3, 4. I only need this 4, right? But then I have this extra bead. I don't want to use this bead. So what I do is I take it from the 3 and I move it away. Then I'm left with 7. Does that make sense? Code to the abacus. Yeah, I think so. I think it's a reduction. Because we have our initial number on the abacus. And then when we add the 4, we have no more beads. We have no more to add the 4. But what do? We can utilize the 5. Because we can have the 5, right? It's in here. 1, 2, 3, 4. But I have this extra one that I don't need. But I can't take it away. I can't break it apart because it's all taped. So what I do is I take it away from the 3 that I have. And I have 7 now. I could do it again. Take away the 1. Oh, sorry. Thank you so much. Sorry, Sally. I get it. The last piece on the bottom. Yeah, I think so. Reduction? That's interesting. In mainstream math, they call it compensation. Yeah, I was just looking at it in another way. Yeah, it's very interesting to find it. It's very interesting to be able to see it a different way, just because now we see the numbers. 6 and 1 is the same as 2 and 5. 6 and 1 is the same as 2 and 5. No, Juan, I don't know what that means. 6, 5, 6, take away 5 is 1. If I have 2, 1, 2, add the 5 is 7. If I take away the 5 is 2. Are all the blue beads different? No, the blue beads are all 5. 5, 5, 5, 5, 5, 5, 5. Juan, did that make sense? So if I do 5 plus 2 is 7. If I do 5 plus 1 is 6. If I do 6 plus 1 equals 5 plus 2. Yes, I see it. Yes, I see that. 6 plus 1 is equal to 5 plus 2. Yes, this is more intuitive than I thought. First time seeing the abacus. Yeah, it's really quite interesting on how Yes, it is very interesting how it works. And it's interesting because we don't have to deal with these symbols. So because we don't deal with the symbols, we actually deal with the representation of the numbers. So we could do it again. Oh, I did that. So we could do it again with the 2, right? Here's my 2. So I have 2 on the abacus, and then this is why I use my money. So I have 2 on my abacus, I have 2 pennies. I add the 4, but 4 is too much. 4, I don't have any 4. So I'm going to add the 5, but 5 is too much. I need to take away 1. So I take away 1, my final answer is 6. So I do it again. Add the 5, take away the 1. And then my final answer is 6. Yes. Thank you, Juan. I've always loved math. I always love math. Yes, yes. It's really quite interesting when you can see the numbers. The fact that we could see the numbers, you could do a lot more, which is crazy, which is crazy. Okay, so how are we doing? So that's what adding of the 4. But we could do it again with the 3. Why? Because this is a whole set. We could do it for all of these numbers and we can understand. That's what this book is. This book is all about understanding how to make a 5. That's how this book is. The book, the way it's designed, is how to make a 5. And when we look, I give you the instructions how to make a 3, how to make a 2, how to make a 1, and then I give you extra questions. I give you questions and I give you word problems, hidden words, and color by number, mazes, and then tic-tac-toe and tic-tac-toe. Yep. And then I give you the answers in the back of the book. And there we are. All right. So how do you do big numbers? Okay. So let's do this number. We know how to do this. Let me show you. Let me show you. Is it just adding? No, you could do bigger. You could do addition, subtraction, multiplication, and division. My mind is blown when I saw it lightning fast. Ah, yeah. Yeah, but you know what? That takes practice. And if you want to get there, you can. I don't. My kids don't. But it takes a lot of practice to do it. All right, so here's the question. So we have 1, 3, 5, 7. And what we're going to do is we're going to add 24, 31. We have 20. Do we add the 2? Is there enough to add the 2? Yes. Yes, we can. We can add the 2. All we got to do is add the 2. So then we have to add the 4. Can we add the 4? No, we can't add the 4. We don't have enough beats to add the 4. But guess what? We know how to add the 4. Remember how to add the 4? This right here? So if you look, plus the 5 minus the 1. And then plus 3. And then plus 1. That's it. Plus the 5 minus the 2. Not minus the 2. It is, 5 and 2. That's what it is. So then your answer is 7. So my final answer is 3,788. That's it. So it's scalable. So it doesn't matter where the column is. It's always about the specific number, right? Just like how we do it here. Yes, thank you, Edward. Yes, this is going to help. Oh, good. Oh, good. Yeah, take it slow, right? And so, I mean, that's what it is. It's like it's easy when you understand the concepts. Then we can go into something higher. But the first thing is you need to understand how to put your jacket on and how to take your jacket off. Right? You need to understand the basics. That's why I go through it. I know it's simple. I know this is simple, but understanding this, then you can scale it. You know what I mean? So let's do it again. We can do 1,221. I want to add 2,000. Can we do it? Yes, we can add 2,000. There's a 0, there's a 3. How do you add the 3? How do you add the 3? You know how to add the 3. We've done it. Add the 3 is plus the 5 minus the 2. That's what this is. That's what we did here. Plus the 5 minus the 2. That's what we did here. Plus the 5 minus the 2. And then we add the 6. Can you add the 6? Yes, you can add the 6. There you go. We are adding the 6. And then my final answer is what? 3,257. It's time for me to brush up on my Khan Academy. Ah, that's interesting. I actually don't know if Khan Academy does abacus. Why does... Yeah. Yeah, it can be really fast because you know what it is because your brain can do a split second idea, right? Can do a split second thinking. Whereas if you did it here, right? If I just showed it to you, we have to think, okay, what does 6 look like? How do we add 6? How do we add the 3? But on the abacus, we see our numbers, so then we just know to move it. And then we could do it again. It's called Slice. Healthy soda. They teach math rules in their videos. Oh, interesting. You know, that's really interesting. I'll have to take a look. I keep forgetting about Khan Academy, but I have to take a look. And then it's another thing. Let's do it again. We have 26 on the abacus, 26. And then we're going to add 32. Add 30, add 2. Add 3 plus the 5 minus the 2, add 2. So my final answer is 58. So what did I just do? What I did was I learned how to make a 5. And then we could do it again with making it a 10. But then after that, we can go into multiplication and division. But I don't know if we're going to get to that because it is getting late. But we're going to continue on. So that is about how to make a 5. And the idea with this book was to solidify and practice and make it automatic. Make it automatic on how to make a 5. I do give you the answers in the back. But the idea is to understand, to get it really solid and to make it automatic. Because the thing is once you know how to make a 5 and you know how to make a 10, you will be able to scale your concept of adding and subtracting. You just need to know these numbers, and you just need to know this concept and how they work together. You can add and subtract at scale. It doesn't even matter. It doesn't matter how big the numbers are. It doesn't matter how many the numbers are. You can do it at scale. Whereas in mainstream math, in mainstream math, they give you all these little different options how to do things. Let me see if I can find one. Let's see if I can find it. I mean, it's fine to have all these options, but I feel like that they're overcomplicating, or they're making it more verbose than it really needs to be. Because the problem is what? The problem is if it becomes too verbose and you have all these strategies in your head, then how do you go to bigger concepts, right? The bigger concept is what? The bigger concept is what? How do you find the interest rate? Well, if I'm trying to figure out how to make how to subtract, and I have to make it a friendly number or whatever, then I got to go multiplication. Well, after multiplication, what other strategies do I need to remember? You know what I mean? But if we only know how to add, subtract, multiply, and divide very simply, because it's not that complicated, then we can have other reasoning. We can have our brain to think about other ways to figure out more complex math. Abacus is the gateway to complex math. I'm not saying abacus is the end all. What I'm saying is abacus helps solidify and simplify basic arithmetic. That's all it does. It just helps simplify basic arithmetic, so you have more room in your brain and more space in your brain to understand how to find the interest rate. I mean, that's big math. You know what I mean? I don't teach how to find the interest rate. What I teach is basic arithmetic. How do I make it as simple as possible to add and subtract, multiply and divide? I'm sorry. What are we talking about? I can't wait for that live. What live are you talking about, Miss Garden Lady? I'm not sure. Thank you. Do you have to move the beads differently based on subtraction? No. No, that's what we're doing. If I have 9 and I want to take away 2, that's all I'm doing. It's not different. You know how to add, you know how to subtract. Let's do 5. Let's do 5. To learn multiplication with the abacus. Oh, okay. Yeah, we'll go into that. Yeah, so here, you know how to add the 5. You know how to add the 4. We did that, right? We added the 4. We add the 4. We plus the 5 minus the 1. See how I bring it down like that? So guess what? If I want to take away the 4 is the opposite. Minus the 5 plus the 1. Do you see that? So now you're seeing a number pattern. Plus the 5, minus the 5. Plus the 5, minus the 5. Plus the 3, minus the 3. plus the 3 minus the 3. Easy. I see. Yeah, we will get to multiplication, division, depending on the time. Math is like building blocks. You need to understand the basics to get to the... Yes, exactly. Thank you, Poke Bites. Yeah, right? Does that make sense, Matthew, what I just did? So when we add, right, plus the 4, plus the 5 minus the 1. And then when we subtract, we do it the opposite. It's exactly the same, but just reversed. Addition and subtraction are opposites, just like multiplication and division. Exactly. But in public school, in mainstream math, they teach you two different strategies. One strategy, like learning the doubles, memorize the doubles. You can't memorize the doubles for subtraction because that just gives you 0. So it's interesting that when they teach mainstream math, subtraction, they give you a separate set of strategies. Whereas in Abacus, it's the same concept. You add, you subtract. You know what I mean, Juan? Right?
Oh, I can see everything.
Yeah, and it's very interesting. It's very interesting with all the different strategies that mainstream math has done, whereas Abacus just makes it simple. So we could do it again with the 3, right? And here is 7. I have 7 on the Abacus. I'm going to what? Minus the 3 is equal to minus the 5 plus the 2. Minus the 5 plus the 2. So my final answer is 4. Yeah, it's crazy. It's crazy on how simple it is, and yet mainstream math, they make it more complicated than it is. What did they say? It's like gatekeeping with language. That's the funny part. It was like gatekeeping with language. I had it all written out. Mez. Hello, Mez. You just came in, didn't you? Because I've been on for about an hour. Let me see if I can find my paper. I'm going to find my paper. Oh, here it is. Here it is. Yeah. It was like traditional math overly verbose. I'm going to have to come back for this one. All right. All right, Zin Zin. Thank you so much for joining. Me either, miss. So let's do it again. Let's do a review. Thank you for commenting, though. Let's do a little review. So this is my reckoning bar. This reckoning bar is what tracks our numbers, because anytime the beads touch the reckoning bar, this is what's being counted. This is 1. These are all zeros. So when I have this touching my reckoning bar, this is counted. So we have 1, 2, 3, 4, 5. The top bead will always be 5. We have 5. We have 5, 5, 5, 5, 5, 5, 5. This is 0. If I do this, this is 5. Now we have 6. 5 plus 1 is 6. 7. 5 plus 2 is 7. 8. 5 plus 3 is 8. 9. 5 plus 4 is 9. And then we have 10. 10 is a 1 and a 0. So what's after that? Well, how do I know what I'm doing? Well, every column is a place value. Like that. Every column is a place value. So we have our 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Excuse me. 10, 20, 30, 40, 50, 60, 70, 80, 90. Right? After 90, we have 100. If you look, 1, 10, 1, 0. 100, 1, 0, 0. 1,000, 1, 0, 0, 0. And then 10,000, 0, 1, 0, 0, 0, 0. Does that make sense? Yeah, simple to use, easy to understand. Hello, everybody. Hello. Thank you so much for joining. Hello, everybody. How are we doing? Right? What about a million? Well, this one is not big enough. So that's why you would have to change it to a 13 column abacus. And that's a very good question. Thank you so much, Sinsin. So when we're looking, if I did this, if I said that this is my ones place, ones, thousands, millions. So million would look like that. There you go. That's a million. 1 million, 2 million, 3 million, 4 million, 5 million, 6 million, 7 million, 8 million, 9 million. There you go. And then we have our thousands. So 9,000,001. Yeah. That one is available in my TikTok shop as well. Thank you everybody for joining. Thank you everybody for joining. I have Abacus books as well as Abacus. For those of you that are interested, I do have it available in my TikTok shop and I do have it available here. My name is Lynette and I've been teaching. Thank you so much for joining. Thank you for the heart me. If you're looking for Abacus books, I do have it available in my TikTok shop. I also have it available here. My name is Lynette. My grandpa learned how to use one of these in World War II. Oh yeah, not a problem. You're welcome, Matthew. You're welcome. Oh, not a problem, Garden Lady. Thank you. Thank you, Zinzin. Trinity, I wonder, does your grandfather know the one bead on top, four beads on the bottom? Oh, thank you so much for the heart. How do we do multiplication and divide on them? Well, we could do that right now. Okay. Trinity. So I wonder, does your grandfather? I don't know if you can ask, but I wonder if it was a 1 and 4, or if it was a 2 and 5. That's what I wonder. All right, we can go into multiplication, but you're gonna have to. But the one caveat is you need to know your multiplication table. You need to know your multiplication table. You need to know how to go all the way to 9 times 9. That's all it is. So here are my books. I do have these books available. 2 and 5. Oh, that's interesting. So that's what you call a Chinese abacus. And if you're interested, this is what it is. I do not sell Chinese abacus, and I do not teach Chinese abacus. I teach Soroban. I teach the Japanese abacus. Japanese abacus is more modern. The Chinese abacus has been around for a long time, but the Japanese came around and made it more efficient. So if you want to know how to read the Chinese abacus, it's the same thing. We do 1, 2, 3, 4, 5. Because we have 5, we want to trade it in. That's what 5 is. On the Japanese abacus, we do 1, 2, 3, 4. There is no trading in. We just do 5. Then we can do 6, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, and then 10. And then we can trade it again because we have 5 here. We can trade it into that. Now this is 10. We have to trade it again. Because this is 10, I do this. On the Japanese abacus, I do 5, 6, 7, 8, 9, and then 10. There is no trading in on the Japanese abacus, but in the Chinese abacus, you have to trade in. Hopefully that makes sense. Yeah. I don't teach the Chinese abacus. I teach the Japanese abacus. And my books are all Japanese abacus related. All right. So. Oh. Oh, hey, I'm back. That took a little bit. I don't know if anybody else is here. Sorry. My internet just completely crashed. There you go. Sorry. I'm back. Okay. He was learn in China before they complete an embargo. Oh, hey. That's really interesting. The Chinese abacus... I'm sorry. The Chinese abacus is very different than the Japanese abacus. What they do is they count up. They count up as opposed to using formulas. All right. Hi, everybody. I don't know if you're still here. Excuse me. Thank you so much for joining. I just had some technical difficulty. Garden Lady, are you still here? Whew, let me know. What we're going to do is we're going to do some multiplication. Thank you so much for liking the live. Thank you guys for sticking around. Okay, so the first thing we're going to do is we're going to do distributive property. Distributive property is what? Distributive property. Hi, Edward. Thank you so much for sticking around. So distributive property is when we take one number and we times it, and then we take another number and we times it. That's what distributive property is. So the first thing we're going to do is we're going to understand 6 times 4. Oh no, before we got to do is we got to number, we need to understand where are we going to put our answer. We know that there's 3 digits here. We know we're going to be somewhere in the ballpark of the hundreds. Our answer is going to be somewhere in the hundreds. So we know 6 times 4 is equal to 24. So we add the 2, 1, 2, we add the 4. There we go. And then what's our next number? Our next number is 9 times 6 is equal to 54. Is that right? 54? Yeah. Add the 5, add the 4. So my final answer is 294. 294. That's what that is. So we have our next number and our next problem. So again, our distributive property, we're going to figure out our positioning. So we count 1, 2, 3. 1, 2, 3. We do 3 times 1, right? 3 times 1 is equal to 3. 3 is a single digit. We need to make it a double digit. To do that, we're going to do a leading 0 and a 3. So that's going to tell us that we have to do a 0 and a 3. 1, 2, 3. And then we do 5 times 3. 5 times 3 is equal to 15. Thank you, Prince. So we have 5 times 3 plus the 1 plus the 5. I'm sorry, plus the 1 plus the 5. So my final answer is 45. So my final answer is 45. And our next question. So our next question is 81 times 2. So 81 again, what we're going to do is we're going to do 8 times 2 over here. 8 times 2 is equal to 16. Add the 1, add the 6. And then 1 times 2 is equal to 2. Add the 2. So my final answer is 162. That's what that is. 162. So now we have our next number. Hello, everybody. Hello. Welcome, welcome, welcome. Thank you so much for joining. We're doing some multiplication on the abacus. And we're doing distributive properties. So the idea of distributive property is timesing each number. So we had times 4 and then 4 times 1. So the first thing we're going to do is understand that we're going to be over here. So 4 times 2 is equal to 8. 8's a single digit. I go back 1 column, I add the 8. And then 4 times 1 is equal to 4. Add the 4 is over here. And so my final answer is 84. How are we doing? I don't know if anybody else is here. All right. So, anybody here? Hello. Thank you so much for liking the live. Wow. Thank you guys so much for liking the live. What we're doing is we're doing multiplication. So for those of you that just joined, we're going to do some review. So we're going to count 1, 2, 3, 4. Anytime the beads are touching the horizontal bar, it is being counted. So we have 4. 1, 2, 3, 4. And then we have 5. The top bead is 5. Because the top bead is 5, then we have 6, 5, 6, 7. 5 plus 2 is 7. And then 8, 5 plus 3 is 8. And then 9. 5 plus 4 is 9. And then this is what 10 looks like. 10 is a 1 and a 0. So then we have 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and then 20. That's a 2 and a 0. Well, how do I know what these are? I know them because every column is a place value. So we have our ones, our tens, our hundreds, and our thousands. Ones, tens, hundreds, thousands, and 10,000s. So when we look, this one happens to be 2, right? 1, 2 in the tens column. So we have 21, That's what 21 looks like. And then we have 22, 23, 24. 2 and a 4. So anytime the beads are touching the reckoning bar, this is the reckoning bar, it is being counted. We have 4 and then we have 5. 5 is always going to be the top bead. We have 5, 5, 5, 5, 5, 5, 5. This is not 5. This is 7. How do I know 7? 5, 6, 7. Because the 2 beads at the bottom is touching the reckoning bar, it is now being counted. So we have 5, 6, 7. So we have 5, 5, 5, 7, 5, 5, 5. How are we doing? So for those of you that are interested, I do have this abacus available in my TikTok shop. It is available over here. So what's with the dots? Oh, that's great. Thank you, Sean. So is the dots to help show that the ones? No, the dot is to help show the ones and the thousands. So their dots are being groups. They're grouping. So ones and the thousands. So if I have my other abacus, which is over here, right? These are grouped. So we have our thousands. I'm sorry, we have hundreds, thousands, millions, billions, and then trillions. And then this one, so thank you, Sean, for the question. That's what that means. So these are the groupings of the groupings of the commas when we do math, when we do numbers, excuse me. Okay. So thank you so much for liking the live. Thank you so much for liking the live. I believe I'm going to end this pretty soon because it is pretty late. So, Sean, do you have any other questions before I sign off? Yeah. Oh, you might be wondering about these two. These are decimals. Because these are decimals, right? Because these are decimals, it happens my ones, and then my decimal sits between my ones and my tenths, and then I have my hundreds. So we can count 1, 10,000, 10, 0, 1, 0, 0, 0, 0, 0.00. Do you go, that's what 0 is. You could start from 0. Or you can count from whatever number you want. You can count from 5. 5, 6, 7, 8, 9. Dope. I didn't realize it count decimals on the base. Yeah. Yeah. It's really quite interesting. So like if I did this one, right? If I had this, right? It'd be 99,999.99. What does that mean? 9999999. That's what that would mean. However, if I did it the other way, if I choose this one to be my ones place, then I'd do this, right? Then I'd have a different set of numbers. I'd have 9,900, 99.9999. And then it goes on. Yeah. Oh, hey, you're back. Thank you, Flex Healer. Yeah. Nice. Oh, hey, hello, nice tree. So, yeah, and that's what that would be. So it just depends on what you're trying to do with the abacus. It's all about how big your numbers are. If your number is big, then you could use this one as your ones. If your number is small, then you use this one. And so it doesn't matter. Ah, good. I'm so happy. Thank you, everybody, for joining. So this is the abacus. It is an Asorabon, but I think I'm going to sign off. Thank you for the follow. Nice tree. Okay, sweet. I should have learned. Yeah, you know it's crazy. If you could do this, right? Is it 9? I'm sorry. 999 is. That's what 999 is. 666 looks like this. That's what 666 looks like. Yeah, I think if you could see the numbers, you'd be way better off, as opposed to trying to figure out how to read the symbols, because don't forget the numbers are very symbolic. Yeah, 999 looks very different than 666 because it's 3 extra beats. 1, 2, 3, 1, 2, 3, 1, 2, 3. What's 111? 111. That's what 111. 111. Right? 2, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5, 5, 6, 6, 6, 7, 7, 7, 8, 8, 8, 9, 9, 9. I'm glad. Oh, thank you, Sean. I'm happy to be able to help. I'm happy to be able to show Abacus to the Matrix.
Welcome to the real world.
Yeah. When you can see the numbers with the abacus, you can actually do a lot more. So you can actually add, subtract, multiply, and divide on the abacus. Yeah. So we can do that. And then if anybody's interested, I have books available in my TikTok shop or available here. My name is Lynette. I've been teaching abacus for about 20 years. So the blue beads, yes, exactly. Nice tree, yes, right? This is what 5555555. That's what that is. So when we're looking, right, we have 5 comma 555. What are you doing? 55555.55. That's what that is. Does that make sense? Oh, excuse me. Yeah. Oh, yeah. No, it's good. It's good. Thank you for the question. Or you know what? Right? It's the same thing. If I choose, yeah, yeah, it's all good. Let me know if you have any more questions. But for the most part, you could do, yeah, you can do adding, subtracting, multiplication, and division on the abacus. But for right now, the first thing we need to do is understand how to read the abacus. When you know how to read the abacus, then you go into a higher math. But this is the gateway to complex math. Abacus is a gateway to complex math. There's nothing, abacus doesn't do calculus. Abacus doesn't do geometry. Abacus is just arithmetic. It's adding, subtracting, multiplication, and division. So, any other questions before I sign off? But again, my name is Lynette, and I've been teaching abacus for a while. I have activities. Oh, so I'll give you a run through on an activity. So, I've been wanting to learn. Oh, hello. I can't wait to learn more. Have a good evening. Oh, yeah, thank you, Sean. I don't have any more, but I'm going tonight. Yeah, yeah. I'm going to go, so I have a question. But I'm better at math. Hello, Prince. It's really interesting. I do have another person that is really good at algebra, but not so good in arithmetic. So, Saint Christy, if you're still here, we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. That's what 10 looked like. That's it. Oh, excuse me. So you might be wondering, why am I over here? Every column is a place value, just like that. Ones, tens, hundred, thousands, 10,000s. That's it. Yeah. Thank you, Miguel. I am going to head to sleep. Thank you everybody for joining. Thank you so much for joining. Thank you for the questions. And if you have any more problems or any more questions, please follow me and I will answer your abacus questions. Not a problem. Thank you. Thank you. Oh, good, Alex. Happy. Thank you for the follow. Yeah. I'm always on. I'm on in the mornings, I'm on at night. But today I had some technical difficulties. But thank you again, everybody, for joining. And this was all about math abacus. If you're interested, I do have books available in my TikTok shop or over here. My name is Lynette. I've been teaching abacus for about 20 years now. Excuse me. And I'm trying to relate abacus to mainstream math. And so a lot of my teaching is how do I bring abacus to mainstream math, like public school and stuff. So, thank you everybody. Have a good night. I will see you all in my next live. Thank you again, everybody. Toodaloo, kangaroos. Bye, Alex. Good night, Edward.